Hey everyone, I just wanted to do a special recitation regarding the Git flow and also API interactions to get you all set up for build weeks. Um, and so I wanted to get started with the Git flow of collaborating with other people. You'll see here I have a Git organization that was actually my build week group for React. And if you haven't done so already, you're going to need to create a repository for the front end. You can do that with this new button right here. You may have to fiddle with permissions to make sure that you have the rights to create repositories and perform other actions within the group. If you don't, you can ask the person who created the group to add you as an owner to the group. For now, I'm just going to do this with a normal repository just to avoid sending those people a bunch of emails and potential permissions issues. But you click the new button and you get this screen. And this allows you to create a new repository. You're going to name it. I'm going to call this recitation git flow. We can add a description if we want. You're going to want to make it public. I don't do this. I don't want to start it with anything. I want to just have it be bare so that way I can drop my React app in there and we're good to go. So I'm going to create this repository. And then I get this page where nothing is in here. So I'm going to need to add something. They tell us exactly how to do this. Always read the instructions. Read this whole page. It's helpful. They put it here on purpose. So what we're going to do is we're going to create a directory on our computer and we're going to run these commands. Git init to create a Git repository, add a commit, and then git remote add origin blah blah blah. So we've always talked about this origin thing when doing like git pushes and git pulls, but we've never really discussed what it is. And it's basically a variable, an alias for the URL we would use to clone our project. And yours might look more like this if you're using HTTPS. So origin is just setup of, where does the remote repository exist? And then we're going to push our changes to origin master. So I'm going to do exactly that. I'm going to, inside my terminal, I'm going to make a directory called recitation git flow, and let me pump up the zoom on that a little bit, and then I am going to cd into there. I'm not going to create a React app here because that takes time. I just want to show you how the Git process works. So if I wanted to do that, I would do create React app, my app name, but now I'm inside of the recitation git flow directory. So instead what I would do is I would do, npx or create React app or whatever, create React app, recitation git flow. And I would do this, and now the root of my repository is going to have my React app in it, but I don't want that. And you can see it already had tried to start setting some stuff up. I'm going to delete those files. So I'm going to add a file. Let me open up my text editor here. And I'm going to add a file. I'm just going to add a readme.md. And I'm going to say recitation git flow. This is some content. Because fundamentally, everything we're going to be checking into our repo, everything we're going to be committing is going to be text. So it doesn't really matter if it's code or a readme. The process is going to be the same. I'm going to flip back to my terminal. If I do git status, this is a great error message I just ran headlong into. Fatal, not a Git repository. Well, why is it not a Git repository? If I do ls-a, it will show me all the files in my directory, even the hidden ones. So we see readme and then also // which is the current directory, and // which is the one above us. What we don't see is a directory called .git. .git is the magic place where all of our Git stuff lives. If we want to create a .git, we do git init, just like GitHub tells us to. And this tells us we've initialized an empty Git repository in where we are .git. And if I do ls-a again, we'll see we now have this .git folder that contains all of our different branches and our commits and all of that information. Now if I do git status, we'll see that I haven't added this file yet, so I'm going to do git add readme, and then I'm going to do what GitHub has told me to do. I need to add the origin to my project. I need to tell this .git folder where GitHub is. So I'm going to run that command. Now I can do git push origin master. Now I can't. What did I forget to do? I forgot to commit. Important to read these instructions. These are the errors you're going to see if you don't read the instructions. So we get this cryptic error, failed to push some reps to my GitHub. Well, at least it's trying to go to the right place. Right now I don't have any commits. We're starting from scratch. So I need to do a git commit. And I can make that message whatever I wanted. Now I can do git push origin master. Notice that what I've done is in the master branch. Previously, we haven't wanted to do any work inside of the master branch because we want to do all of our changes in a named branch and then merge those in when we're done. And that's exactly what our normal flow is going to be. But we need some place to start. So you need one person in your group to run create React app, commit all those files, and then push that up to GitHub so you have a master to start with. It's not, you're going to run into issues if you all start with an empty repository and then create your own React app with name branches and try to merge that in later. That's a big no-no. So you need master. You always want master to represent the the shipping build of your application. What is the standard version of what's going on? So it's going to start as a bare React app, and then we're going to branch off of it and perform our changes, which I'll show here. So just like normal, I'm going to do git checkout -b Henry Blevins, because I don't want to commit directly to master, because if I commit directly to master and someone else tries to, we're going to run into issues. I want to spend my day working on trying to get my component or whatever correct, and then I'm going to create a pull request, and then it's going to get merged into master. And this is why we've been preparing you in this git flow. So now I'm inside of Henry Blevins, and if I go to the README file, I can add more stuff. This is a change. Great. And now if I go back to my terminal and do git status, we'll see that I've modified the README. I'm going to add it. I'm going to commit it. And then I'm going to push it to my named branch. So if we see here, we now have our name branch Henry Blevins. It has some changes in it. And if I want those in master, if I'm happy with the changes I've made, I'm going to create a pull request. So just like normal, we're merging onto master. This is where you want to add reviewers. This is where this is actually really important. You want to add the team members that your changes are going to affect, which are going to be your other React devs, because they didn't write this code. They don't know what it does. They don't know what changes it's added. So if we add them as reviewers and then create our pull request, you can see they will have a button here that says add review, but we can access that view with this files changed tab. If I click on here, it will show me every single line of code that this commit has changed. These greens with the pluses are lines added. If we had removed lines, they would be red with a minus. And so your team members can go through here, look at your changes, the exact changes you've made, and be like, oh, okay, this is fine, or oh, no, you can't do it this way. I am doing this other thing, and it's better if you do it this way. And then you can push up another commit, and then once everyone has approved the changes, then you can go ahead and merge this pull request. So we're going to assume that my changes are good, and I'm going to merge this pull request. But before that happens, I'm going to pretend that I'm another developer on the team. So just like Henry Blevins, Bard Belvins, cloned the project. I'm in my master branch, and I'm going to do git checkout -b Bard Belvins, and now I'm in here, and I'm going to make my own changes. So let me refresh the contents of that file. Watch what happens, because now when I merge this pull request, I've just changed the master branch. So now Bard Belvin's branch is actually based off an old master, and it's going to have conflicting changes. So if I go and add my changes in Bard Belvin's, git add readme, git commit, my changes, git push, origin Bard Belvin's, we're going to see our first merge conflict. And you'll notice this when you go into here and GitHub suddenly throws an error at you. Can't merge automatically. That's because in Bard Belvin's version of the master branch, in his version of the code, in his branch, there were no changes from the Henry Blevins branch. But since I did the git merge, since I did the pull request merge, now the master on GitHub is different than the code on Bard Belvin's computer. And so we'll get this error, can't automatically merge. I can still create this pull request, but Git is going to show me that there's a conflict, that we both tried to modify the same line of the same file. And we can resolve this here on GitHub by clicking Resolve Conflicts. And we get this interface that's just a text editor. And we'll see this format. This is called a diff. So it shows me the changes made in each branch. So we would call this the incoming changes. The incoming changes from Bard Belvin's, my own changes, and then the current changes, the ones on the master branch. This is a change. To resolve this conflict, I just need to get rid of these arrows and these equal signs. Because this is just a text editor. This is not some fancy other system. It's literally inserted this text into the file. And this isn't valid Markdown or valid JavaScript or valid CSS or whatever. So ultimately, I need to pick what code shows up. I could have both show up, if that's what I want. I could only accept Bard Belvin's changes. Or, you know what, maybe this is actually bad. This is just a text editor. I can do whatever I want. And when I click Mark as Resolved, Git will actually add a new commit with these changes resolved to it. But when we get into more complicated changes, it's probably better if we don't handle them directly inside of this Git interface, because our text editor is well set up to handle these conflicts. So what we're going to do, and what you should do whenever you know someone has merged a pull request into master, which you should know because you should have signed off on it, is we can pull the changes from the master branch down into the Bard Belvin's branch. We do that by saying git pull origin master. And that's going to take all the commits from origin master and try to put them into our current branch. And it's going to do that, but we get an error, and this is exactly what we want. It says automatic merge failed, fix conflicts, and then commit the result. So we've run into this exact situation that we have on GitHub, which is that we can't automatically merge all these commits together. So we're going to have to manually resolve it. And if I look back in my text editor, what do you know? It's the exact same thing. These arrows with our incoming changes and these existing changes. Now the branch names are a little bit uglier. This is a commit hash. Head represents my current commit on my current branch, but same thing. Incoming changes, existing changes. To resolve this, I just have to delete these lines and then leave whatever code I actually want in the file. I'm going to show you how this looks in VS Code. Let me find my terminal. So I'm going to open VS Code here. VS Code is actually pretty nice to us. It will recognize that this is a merge conflict, and we get these buttons we can click. So if I want to accept the current change, I can do that. Or I can accept both, and we have all of these nice options for us. But fundamentally, we're just going to resolve the differences between this text. I'm going to have both in here. And then we commit it like any other change to our code. If I do git status, we'll see that I have modified a file. So I'm going to add my file. I'm going to commit it. Resolved merge conflicts. And then I'm going to push it to origin Bard Belvins. So now when we push changes to our branch we have an open pull request on, they get added automatically. And now look, I've resolved those issues and I can merge that pull request. And after everyone signs off on these changes, that I resolved the merge conflict successfully, you know, that I didn't accidentally break their stuff when I do that, we merge this into master. And then everyone else, they should probably get to a working point in their code where they can commit, then they can do a git pull, get the updated changes from master, and then when they go to make their pull requests, there won't be any merge conflicts. You can also just, before you try to make a pull request, do a git pull origin, master, make sure you got everything, make sure you resolve any conflicts. VS Code will show you in the file browser view every file that has a conflict in it. And when you're done with that, just commit those changes, push them up, make your pull request, and you should be good to go. So, questions with this? Yes, Emily. After changes have been merged, it's a good idea to do a git pull. Make sure you have your current changes committed before you do that, because you want to, in case something gets goofed up, trying to do, trying to resolve these merge conflicts, that you can always go back to your working code. But yes, whenever changes are added to master, it's a good idea to get those changes so you can work with the most updated project. And we do that with git pull origin master. What does git fetch origin accomplish? So pull will download the latest changes from origin and try to put it into our current branch. There's also a command called git fetch, which hopefully this prints a oh no, it just did it. Okay, git fetch, help. So git fetch downloads commits from the repository and puts them in their appropriate branches. So when I just ran git fetch, we can see that it downloaded these changes from origin master and put them in my master branch. And so this way, I could just do git pull master. Because my master branch has all the updated changes, I don't have to specify that I want the origin master. I prefer that you all just do git pull origin master so you don't run into any issues where you keep doing git pull master and you're like, I'm not getting any merge conflicts, it's fine. And it's because you forgot to actually pull the new commits, which we're all going to be guilty of at various times. So you can just do it this way, just to be sure. Okay, Tatiana asks, what are the pros, cons of naming branches after specific components versus our names? So, most often, I would guess, I would assume, developers work in what are called feature branches. So you name your branch off of master, whatever feature you're working on. So if you're working on the forms component, you can call your branch that. And then when you're done, you can open that pull request, do it, and then when you're done, you can just straight up delete that branch. No one's ever going to need it again. And Git actually tells you, or GitHub tells you, yeah, you can just delete this branch now. You don't technically need it anymore. The advantage of this style is that if I open my pull request and then I want to do more stuff, if I'm still on my named branch and I commit and push more changes, that'll show up in this pull request. I can't isolate those. And so working in individual branches gives us the power to open essentially multiple parallel pull requests. The overhead it adds in terms of keeping track of your branches and those multiple pull requests is kind of the downside. It isn't as necessary in this project where you're collaborating with a few people and your responsibilities are going to be, clearly delineated as to who's going on what. Named branches make it a bit easier if multiple people want to collaborate on the same branch at the same time. So you can see this model extends out further. So you can have a feature branch that has, branches off of it for people to work on and then, pull their changes into the feature branch and then push those up and then when that's ready. And so Git lets us do a lot of these things. We could all just work in master if we really wanted to. But at least having the flow of doing your work in a branch and then pull requests to get in, that's going to alleviate most of the pain. Strategies for branching and doing all that successfully are a hot topic. Lots of contention, lots of strong opinions. For now, I would say probably just stick to the named branch just because debugging Git errors is super valuable. It's going to make you a better developer, but it might not be the best use of your time this build week. So, Jason asked, should you pull someone else's branch if you're working asynchronously on the same components to keep everything copacetic? If you're working on the same components together, I would say either do pair programming. Like if you're going to be working like right up in the same file on the exact same lines of code, probably just pair program and just avoid the Git issues altogether. But if you're working on the same feature together, this is a case where you can use a feature branch. And you can treat that feature branch like a mini master branch. When I make pull requests, I can make the target, it doesn't have to be master, it can be whatever I want. And so you can expand this Git flow into feature branches. But if you're really going to be getting in your way, probably just communicate those changes physically rather than trying to deal with, how to do commits and all these errors and stuff. So, yeah. Any other questions with this? No? We're feeling good with our basic Git workflow? You'll run into more issues as the week goes on, and if you have them, please tell me more ideas of things I can cover this week that would be helpful. I see Tommy typing, but I will get ready to transition into APIs. So Tommy asked, so just to be sure, I got the person to create a master and then everyone else fork from there. We're not forking. We're not forking. We're going to be working on the same repository, but we're going to be doing it in different branches. Right? So we're all working on the same repository, and we're all working on the same repository in our Git org. We're going to download it, we're going to make branches off of master, we're going to push up to our branches, and then we're going to create pull requests into the master branch. We could fork with essentially the same workflow, but it's going to be a lot more work trying to get the master on your fork updated to reflect the current changes within the the GitHub org's master. So no forking, just branches. Oh, Dennis is asking if I can upload this as a separate video. I think that's probably a good idea because I may get cut off here by an all hands TL meeting later, and I'll start it up again and recover for that. But let me just ask for any final questions on Git, and then I can stop and start the recording and upload this on its own. All right. Any last questions? Okay. Well then, I'll stop this recording, and I'll see you all in a second.